Okay. I think something is there's some issue. So I think now it's visible, right?
Yes, yes.
Is this top part of the screen, is it annoying? I mean, is it, can you see that as well, or is it fine? I think I'll just leave it here.
This is fine.
Okay. Okay. So yeah, welcome everyone. Today's webinar is on CICT, which stands for Continuous Integration and Continuous Testing for Embedded Development. So a little bit about myself. I'm Vishnu. I've been working with ANCIT for the last 3 months. I'm into embedded systems and mostly within embedded systems into communication protocol like I2C, SPI, CAN, mostly to do with their driver development, bootloaders, and of late I've been working on ECUs for automobiles and automation for embedded systems. So in today's webinar, we will let me give you an outline of what's going to happen. So first, we'll take a brief look at what exactly is continuous integration and continuous testing. Then we will see the essential pipeline, the integration, continuous testing pipeline for embedded systems. And in that, we will see that it becomes slightly important that we know CMAKE and how to use CMAKE. So I will also give you an introduction to CMAKE. And then I will show you how exactly we have configured an STM32 board with CMAKE and GTest. So we will also be discussing a bit about, I'll also show you how exactly to test your system using this particular pipeline. So after showing you this STM32 setup with CMAKE and GTest, then I will give you a brief, not actually a brief, actually an in-depth idea about the Jenkins and GitHub. That's where most of the work happens. Then we will try to put it all together to see how it functions as an end-to-end system. And if time permits, I will give you a small demo of how this can be implemented, how this is implemented. I will give you I'll show you how exactly it works. I cannot show you how to set it up. That's a time-consuming process. So let's start with our basic question. What exactly is continuous integration and continuous testing? So this particular this is a means for making our lives easier in the sense that you can have multiple developers write and update code, and in general you will have these developers you'll have, let's say, 1, 2, or n number of developers sitting and writing a code and depositing into the code repository. And in our case, we will be discussing GitHub as the code repository. So the idea is that these developers will only have to worry about their own code. They don't have to go through the headache of talking with each other and then integrating their code, or worrying that what happens if one person commits one code and the other person commits some other code, and then there is a clash between the codes in terms of some errors, or all these nitty-gritties need not be worried about. So they commit their code into a code repository, and you have a central server which takes care of building, testing, and deploying the code. Okay, so you have the code repository which communicates with a central server. So in our case, the central server is that we'll be discussing will be the Jenkins. I'll get to that in a short while. And once the central server communicates with the code repository, it'll take care of, as I said, it'll take care of the building, testing, and deploying to the final embedded devices. That's the end users. So the developers can commit their code multiple times a day. So you will be sitting at some corner of the world, and then you can commit your code. You don't have to worry about, you don't have to worry about whether or not it's in clash with somebody else's code who's in the same project, who's working on the same project and trying to develop the code. So the central server will detect the commit, and then it will take the action. So in this case, in today's webinar, the action that we are discussing is that it will build the code and then it will flash it into our end device. So this server will also take care of logging the build and test. So that if it will generate any error, if it will generate any sort of a issue, it will generate the log for that, and then it will also create an issue on the GitHub repository, and the corresponding developer can just look into the issue and then close the issue whenever. He can just address the issue, and Jenkins will take care of closing the issue as well. So this will have minimal intervention from the members of the project, and then we can spend more time on development of code instead of trying to put everything together. Great. So now I'll discuss the essential CI/CD pipeline for embedded systems. I call it essential because depending upon the complexity of your project, the pipeline can become bigger and better, and it can become more advanced. So here I'm discussing the basic pipeline for for your embedded systems. So like I said, you will have Jenkins, and I'll discuss what Jenkins exactly is in the coming slides. So you will have Jenkins, and it will fetch code from GitHub. So if the fetching part of the Jenkins is successful, it executes a build script. I'll get into all of this soon. So a build script tells Jenkins what exactly to execute from your GitHub project. Now, if the first part of the build script that we have shown here will be the G test. So it conducts a G test, and if the G test fails, for example, it opens an issue on GitHub. However, if the G test passes, it goes on to build the application layer, which is the application code for your hardware abstraction layer for your STM or in whichever microcontroller microprocessor that you are using. However, if that fails, again, what it does is it does not go further. It will just open an issue on the GitHub, and then the corresponding developer can look into the issue and then fix the code and then push the code back into GitHub. So what I'm trying to say is that the developer does not have to worry about the building and testing part. So, okay, so suppose the build application code is ready and it's building without any error, it then tries to flash the code on the hardware. So here also some things can go wrong. Suppose during the flashing process or the verification process, it could generate some error, or maybe the connectivity issue or something like that comes up, and then if it does not work, then again it will create an issue in the GitHub and it can be addressed. However, if everything goes correct and then the hardware is flashed, it will look for it will see if any issues are open in the GitHub that it created, and then it will close those issues. So now you have a complete end-to-end system over here, and the only part where like the coders come in is where they are looking into the issue, and then they are developing and pushing their code into GitHub. Okay. So, like I said, Jenkins build scripts in at least in this pipeline makes use of CMake. So it allows there are the CMake files available in the project, and using the CMake file, it is able to compile your project. I'll get into what. So the first order of business would be to understand what exactly CMake is. So for that, we will introduce CMake. And as per the CMAKE organization, what it stands for is CMAKE is an open source cross-platform family of tools designed to build, test, and package software. CMAKE is used to control the software compilation process using simple platform and compiler independent configuration files. This part is very important because it gives you a lot of control over your project, how you want to go about compiling it, what exactly which files you want to pull when, and gives you an extraordinary amount of control over the compilation process, which you will not get in other if you've been using like other compilers like Visual Studio or something like that, because the amount of control you have over the compilation process is quite limited. So CMake primarily uses .txt files, and I cannot make this. I cannot stress this point enough. The file structures when it comes to CMake is very important, and the reason is that CMake these for every layer of your project you need a CMake list.txt file. And for example, here I have a basic demo file here, that folder here, that has for the presentation purposes. So inside the folder, you can see on the right side, I have a build folder, and then I have a ex1 folder where my example project is going to be, and example.c file, and then that requires a CMake list .txt. So this is a very simple project, but as your project grows and as you have more number of .c files, at every layer you require a CMake file. I mean, it's not that you require it, but then it improves the efficiency with which CMake compiles your project. So in the CMake list.txt, in at least in this for this project, first you need to give a basic. You need to give this input called CMake minimum required, which specifies your version. You can specify the version here, and then you need to add the project. You can give a name for the project and add the project, and then you need to add the executable. Give the name for the executable and the path for your .c or .cpp or whichever kind of files that you're trying to execute. So in my case, this is what my basic CMake file looks like. Here, the important part is the add executable. So my executable name is example1, and then this is my directory where my example.c resides. So that's in the ex1 folder. So in the terminal, after I make these kind of a setup, I can go to the build folder. In the build folder, I need to run these uh, code. I mean, not code, the script. So you have the CMake these two basic script that first builds your, first generates your build file, and then it builds your, it compiles your project. So let me just show you. This is my basic .c file where I am printing this string called ANCIT webinars. So I have to step into my build directory. So in the build directory, I give this command CMake // whatever it is here. So once I give the command, it generates the build files, and from the build files, once I give this particular command, it generates it compiles the entire C file, and it also generates an executable file for me, which is example1. So which can be run, and once I run it, I get the desired output, which is ANCIT webinars. So this is the basic way to set up a CMake, and then you can build on it depending upon the kind of files you want to generate and the kind of project you're working with. When it comes to embedded systems, there are few more tweaks that you require, you need to link few of your libraries, because depending upon where it's sitting, And then you need to also be very careful about how your whether or not I mean, you have to link this linker file for you, which tells you, which tells the system how exactly your memory is mapped. So that becomes very important. So there's a few additional tweaks that you have, but overall the scheme is the same. Okay, so that's the CMAKE part of it. Now I will discuss with you how exactly STM32 is being configured with CMAKE and GTest. So in the STM32 project that we have, we're using a very basic board. It's the blue pill board. I think it's the STM32F103 series to blink LEDs. The testing part includes a G-test that asserts whether the LED GPIOs are correctly configured. So this G-test will not allow you to go forward with building the project if you do not properly configure your LED GPIOs. So this is built and flashed using CMAKE. So like I said, the project file structure becomes very important. In my case, is the project file structure where I have a folder for GTest, and then I have a folder particularly for blinking the LED. So, and then every layer of my project has a CMAKE list.txt, and then it tells the CMAKE compiler how exactly to pull all the files together, all the .c files, all the include files, how to pull them together and how to execute them. That's the idea. So let me just show you how exactly. So I want to just show you the GTest part and the main part of the program so that you get a basic idea of about how the STM project has been set up. So within the GTest, like I said, I have one more CMake list which tells me to add my hello test.ccc as a executable. So in my hello test.ccc, I have this particular GTest working for me where I am I get the details about my GPIO configuration from this init LED function, which is responsible for initializing all the LED GPIOs. And then I make an expect EQ function to test whether it is the same as what it is supposed to be. So in my in my G-test, I test whether at least this particular part of the G-test, I test whether it is GPIO pin 5 or not, because my LEDs are configured to be at GPIO pin 5 and 4 for port P. That's the basic basic test that I'm conducting here. And when it comes to my main file, sorry, I have the basic program for an STM where you have you're initializing the hardware abstraction layer, and then you have, again, like I said here, it is the init LEDs being called. So this is so before this part is executed, the G-test is conducted on this init LED to make sure that it's initialized properly. And then I have the basic blinky going on over here. So that's it's as basic as it can get for a embedded project. But the overall setup that I'm going to discuss for the continuous integration, continuous testing development cannot be discounted just because you have a basic project for STM, because you could put in a very complex project and it will surely within this pipeline it will still work. So that's the idea. So let's go forward. So now I'll discuss with you Jenkins and GitHub. So this is like a very beautiful integration of two particular softwares. And GitHub, as you all know, it's like a software to store, change, and manipulate and version control, bug tracking, all sorts of manipulation that you can do on your code by multiple users who are working on a project. Jenkins, as per their website, they say it's the leading open source automation server, and they provide plugins to support building, deploying, and automating any project. And this is the most important part, the plugins, and most interesting part. They give a lot of plugins to work with many projects depending upon your choice. one of the plugins that we will be using will be with respect to the GitHub, the two particular plugins. Great. So first we will discuss setting up Jenkins. For setting up Jenkins, it's I'm working on Linux system, so I'll be showing that particular steps. But it is in your Windows also it is straightforward. You would not be running into any trouble that I can force. So to install Jenkins, you need to first install Jenkins, and it's the basic Linux based setup. This is from from Jenkins website. You can just update your system and install Jenkins. And similarly, Jenkins requires Java, the latest version of Java, to run. So you need to install that as well. And there is one third software that you require, which is webhook payload delivery service. This is recommended by Jenkins, and it's called SME. And the reason why this is required is that SME allows your Jenkins that's running on your local server to bypass the firewall and talk with GitHub. You can do this without SME, but then you'll have to go through the additional pain of setting up all your port forwarding services. Right. So these are the three things that you need. You can start Jenkins by giving the following command. And your Jenkins will have a local repository in your system, at least in Linux. This is the path that Jenkins usually takes, and all the jobs that it runs you'll be able to find it in your local system in this particular path in Linux. In Windows also you will have the same, but you will have to look for the particular path. And then you can check the status of your Jenkins if you want to know in which port it's running of your local server. You can check it using this particular command. So once you can log into Jenkins by going to this particular your localhost.808080 is your port number. It can change. Most of the time it won't change, but it can change depending upon your system configuration. And then I suggest you go and look into your if you go back this particular status, and that will give you an idea of which port it's operating. So it will ask you for your password, and this password you can find it from your terminal by just trying to run this particular command. It's in the Jenkins folder itself. It will just catch it for you and give you the key, this particular key, and then you can log into Jenkins. As soon as you log into Jenkins, you will have this. You should take this particular option called Customize Jenkins and install all suggested plugins. This is the standard installation manner. It will install almost all the plugins that's popular plugins, at least it will install. One of the popular plugins is GitHub, so GitHub plugin will be installed. However, there is another plugin we need, which is known as the GitHub Issues plugin. This needs to be manually installed. That can be done once you go to Manage Jenkins. There is an option called Manage Jenkins in the system configuration. You can go there, and then you can in the installed plugins, there's an option called Install Plugins, in that you can just check whether you have GitHub Issues plugin installed. So if both of these plugins are installed, you are ready to go. Okay, so that's the plugins part of Jenkins. Now, I will now discuss with you how to set up a Jenkins job without webhooks. So without webhook means Jenkins will not be able to it won't know when somebody has made a commit on a GitHub. It will have access to GitHub, but then you need to either manually give a build trigger, or you need to set up a build trigger, maybe like 12 at night or 5 p.m. in the evening, something like that. So it will continuously do it, but it will not detect a commit. So to do this, you need to in the yeah. So I think somebody did some artwork there. So anyway, you need to click new item on Jenkins dashboard, and this is your dashboard. In my case, at least, it's called CI/CD demo, and you need to choose this freestyle project, and then you can start with your Jenkins dashboard. So you need to enter this particular description of your project. You can give us some description, and then you need to go to this option called source code management. Under this, you can go to your dashboard. In the dashboard, you will have option called configure, and under configure, you will have source code management. And in the source code management, you will have this particular option called Git. You need to enable that, and then in the repository of URL, you need to give your particular repository. So I have given my repository over here. And is there a way to remove this? Yeah. Good. So in my repository, in my Git, I have enabled my Git, and then in my repository, I have given my particular my own repository from which I'll be building my project using Jenkins. So it also asks you for a branch. In my case, it's main. Suppose if you have a different branches for your project, then you need to be careful in which one you specify over here. So you go to build options, build steps under this particular, in the same under source code management, you will find build steps. And now you can give this option called add build step. Under add build step, there is an option called execute shell. So this particular shell script is what your Jenkins executes while it's trying to build your project. So what it does is it fetches the code from GitHub, and then it executes this whatever command line commands that you have given over here. So this is my, and then you can click save. And then before I go a bit further, I'll just talk a bit about that shell script that I had. So in the build steps, you have the shell script is provided. So this is my shell script on the left. So you can see that I go into the directory called CICT demo, and this is on my right. You have the snapshots from my GitHub. So you have the CICT demo directory, and in the directory I have a .c file. This is the .c file, the basic hello world. So in the script, it goes into this CICT demo. It cross compiles it, and then makes it an executable file, and then it executes, runs the command for executing. That's what Jenkins does once it has access to the GitHub. So in the Jenkins job, you also have an option to build now. It's called build. So you can, once you click it, like I said, you need to either manually build it, or you need to you can set triggers for a particular time of a day or something like that. And once you build it, it will show you a small build status here, and then you can click on that, and you can go to the console of that output. So in the console here, you can see that first what it does is that it clones the repository, gets access to the folder, the repository folder that you have, and then it starts executing the script. Here is the script that it goes into this folder, cross compiles, changes this permission. I mean, it makes it an executable, and then runs it. As soon as it runs it, you get the output, that the desired output as hello world. So you can have any project that you want, and then you can follow a similar step, and you can let Jenkins do the build. You can set it for maybe like 5 p.m. every day or something like that. But this is still without webhooks, as in it won't detect a commit from your on your GitHub. So we will now discuss setting up a Jenkins job with webhooks. So what exactly are webhooks, first of all? So webhooks are automatic. So if you have automated, these are like messages sent from one application to another when a certain event occurs. So in the Jenkins GitHub framework, these webhooks are initiated whenever a developer commits a code on GitHub. So the GitHub notifies Jenkins, and then Jenkins immediately pulls all the, it clones all the repository, and it starts with the build steps, like the shell script over that we discussed. So we configuring webhooks requires me, like I told you before, because it allows you to communicate over a firewall. So to configure SME, first you have to go to this particular site. And as soon as you go into the site, and you can click this option called Start a New Channel. And SME will provide you with a unique URL. You can then install the client server in your PC wherever the Jenkins server is running by giving this command. And once your client server is installed, you can start your client server. And when you start your client server, make sure that you have the URL, the one that SME gave you, this unique URL over here. And also make sure that the port is the same as the port on which Jenkins is working. Okay, so that's the configuration of SME. Next, you need to configure GitHub for SME. So what you need to do is you need to go to your project repository. In your project repository, you can go to settings and go to this option called webhooks. And in webhooks, if you can see here on the right corner, there is an option called add webhooks. And in that particular option, you get a payload URL. So there you can put the same URL that SME gave you, and you can then click this option called send me everything. As in this happens, so this option is for whenever whatever changes happen in your GitHub repository, immediately the webhook will be triggered, and it will send all the details to Jenkins. And then you can just press add webhook and close this. And the next part is configuring Jenkins for your webhooks. So you need to go to a configure option in Jenkins job. There's an option called configure. And then you need to go to build triggers. In the build triggers, there's an option called GitHub hook trigger for Git SCM polling. So this particular option is for, it will keep polling for a, what do you call that, a webhook communication. As soon as it gets the webhook communication, it then pulls all the code from your GitHub repository. So, and then you also, like I said, you also, without webhooks, you have this option called build periodically, where you can mention the time, or every 5 minutes, every 10 minutes, you can build your project. You can make, or every 5 minutes or 10 minutes, you can ask Jenkins to run a job. Okay, so now once you have this option enabled over here in your Jenkins, it'll every time a GitHub commit occurs, it will be triggered. So now I will also discuss. So now we have webhook discussed. Now we will also discuss issue tracker. So issue tracker is from the plugin GitHub issue. So this is a very wonderful plugin, as in if Jenkins, while in the building process, it detects an issue. If it fails, or if there's an error, it will automatically open an issue for you in your GitHub. And later on, if you if you rewrite your code, and then if you fix the code, and then when again Jenkins builds the code, and if it's successful, it automatically closes the issue. So to do that, under manage Jenkins, you have to go to configure systems, and you have to go to this particular part of the configure systems known as GitHub. And in GitHub, you can give your GitHub server wherever it is that your code is. And so what you need to do is, so you need to enter your server, and then go ahead with this. Yes. So there's an option called add GitHub. You can see on the right side, the add GitHub server, and then you can enter your server details over there. And yeah. And before you go further, you also need to, let me just go back. you also need to make sure that you have a personal access token from your GitHub repository. You can get this from your developer, I think developer options easily, and make sure you get a classic personal access token. GitHub is testing a beta with personal access token, and that will run into issues sometimes. Right. So then you also need to go into your credentials options in the same block, and then you need to go to kind. So there you have add credentials, and you need to go to kind and then select secret. It's called secret text. It's just fancy words for personal access token. And then you just need to enter your personal access token here. After you enter your personal access token, you can test the connection between your uh, Jenkins and GitHub by there's an option called test connection. And as soon as you test this connection, it should show that credentials are verified for your account. Great. So that's now you need to go to one more step is remaining, where you need to go to Jenkins Job, go to configure, and then under post build. Now before we had build steps where we had the script where we enable the shell script. Now we need to also create there's a post build action where you can create the GitHub issue on failure. So you can select this option. As soon as you select this option, you will get a you can get a advanced setting option there, in which you can go to issue repository and also enter the URL of your GitHub repo. So it knows where exactly to create this issue. Going forward, so this is the part where it's the post build action. So after the building, Jenkins will create an issue if it runs into trouble. Okay. So let's now see how exactly do we put all this together. At least for what we have developed here at ANCIT, we have a STM32 blue pill connected configured for a basic LED blink application. This application is built and flashed using CMAKE. As I showed you before, we have CMAKE configuration done for that. And then you have the CMAKE.txt files plus the STM32 hardware abstraction layer together in a project, which is placed on GitHub repository. And as I discussed, GitHub webhooks are enabled for Jenkins, and Jenkins is configured for GitHub issue tracker as well. So now you have your STM32, the embedded systems part, which is working with CMAKE, and then you have your Jenkins and your GitHub all together working in tandem. So for that, I'll first discuss the Jenkins build script so if you remember me telling that in the Jenkins tool, you have an option to specify your build script, and that's what Jenkins uses to build your project. So in my case, I go into my this particular directory. I'll show you in a minute what the directory is. It accesses the GitHub, goes into this directory, and then it runs the script, runs CMAKE script. So this particular script is available inside my project itself, and then the script is responsible for all the CMAKE commands, and then it checks if the build is successful or not. So you can see that this is on the right side, you can see that this is my GitHub repository where I have this run_CMAKE script, which can be accessed by Jenkins. So even my CMAKE script is sitting on the GitHub repository, so that my Jenkins build script on the left is very lean and simple. You don't have to write a lot of code here. Great. So that's the script part of Jenkins. Now I'll show you the output log for a failed run, as in I created so as soon as Jenkins detects the commit, it starts pulling in the Git code, and then, as I told you, it goes into the directory and then starts running the CMAKE script. You can see at the bottom over here. And the first thing the CMAKE does, as I told you, is checks for a G test. And in the G test, I I changed the pin configuration such that the G-test would fail. So in my case, this G-test fails over here. It tries to do a basic assertion and there's a failed G-test. Yeah, so sorry. Yeah, so here it fails the G-test, and once it fails the G-test, what it does next is you can it at the end of the Jenkins login, it will show that build has started to fail, and it files a GitHub issue number 21 with my on my GitHub repository. So this is on the right side is my GitHub repository. Now you can see when I go into the issue, it shows that SCM2F1 job failed with this particular number. That's the issue number, and then it gives you the complete log of what went wrong and the complete log of your build, and then you can in there you can see what went wrong and what exactly is the issue. Now I'll also show you the output log for a successful run. Again, it's the same thing. It fetches the code, runs the script. As soon as it runs the script, then this time I had changed the code to make for the correct GPIO pins. So here it has passed the test. G-test has been passed. Then it starts building the code for the STM32 hardware abstraction there. So it builds the code and the target is built. Here you can see that, and then you will have it starts to flash the hardware layer. So my hardware is connected to the same system on which the Jenkins is running. And now, since the hardware is successful, the flashing is successful, it shows build was fixed, closing GitHub issue number 21. So now if I go to my GitHub, it closes the issue by itself. And same issue number 20. So that's the output for this when I put all of them together and see how it works end to end. So I think we might have time for a demo. Do we have a time for demo, Bhishma? It's 3:45. I think I can quickly show you a demo. So I think go ahead with the demo if I can get the screen share correctly. So can you see the hardware on my left side? Or is it if anyone can see the hardware, it's the video of a hardware, then you can just tell me.
Hardware, no, just the PowerPoint.
Oh, okay. Let me just stop the sharing and check it. Maybe you can see now. Is it?
Yes, now I can see hardware, the board.
Yeah. So that's the hardware. So right now the hardware is configured to just blink, I think, every half a second or something like that. So I have also set up my Jenkins server over here. Just log into it. And this is my GitHub page. So I hope you can see the Jenkins server.
No, we are just seeing the board and
Ah,
behind the PowerPoint.
okay. Let me-
Vishnu?
Yeah.
So I'm not able to see your screen.
Yeah, I just stopped sharing, so just to set up this space.
Okay.
I'm not sure if Zoom has the ability to share everything. It just shares just
Yes, I believe that right now it's working.
yeah, I hope I hope it works when I switch the screen. I just changed to terminal, then can you see my terminal?
Yes.
Okay, great. So I hope you can see my text editor as well. Or do you still see the terminal?
I'm seeing the text, the man C.
Great, good. All right. So here on the left side, I have a blink basic code that's blinking, I think half a second or something like that. And I have set up my Jenkins over here. It's running. You can see this is the last build at number 121. I was playing around with it a lot. So it's I'm not going to build it anything. My GitHub configured. So what I'm going to do is I'm going to go to my text editor, and then I'm going to go to my main.c, and I'm going to make a basic change over here saying that instead of running it at half a millisecond, maybe I'll run it at 50 milliseconds. So I'm going to make this change, and then I'm going to just now I'm going to just add the code, commit it, and then push it. So I have to just enter my credentials. So as soon as I push this, you can see that Jenkins automatically starts a job because it detects the push, and then I can go into the console and see what exactly Jenkins is doing. So it starts pulling the code from the repository, starts the G test on it. So the G test is successful here. And then it starts the building of the STM32 code. Build. And it's built, and then it flashes into the STM32 with success. So I can go right now, I can show you the hardware layer. So you can see that this is my hardware. It has been flashed by Jenkins. So I have to give a hardware reset because I didn't enable the software reset. So I'll just give a reset. So now it's you can see the rate at which it's blinking has changed because we changed the code. I can also show you how exactly an issue is created. For example, in this is the part where I have my GPIOs being initialized. Instead of 5, I'm gonna, let's say I'm a developer who accidentally initializes 6. And then I add and commit push my code. So if I go to Jenkins, it starts another job as soon as the push was received. It's queued, the job is queued, and it'll start in a second. Okay, good. So it starts again, another job. So this time the G test should fail because I have set it up in such a way that any wrong GPIO and it should fail. Great. So it failed, the G test has failed, and as soon as it failed, it shows GitHub issue notifier build has started failing. And it files a GitHub here over here, and then I can actually this is my GitHub, and if I go to my issues, it has created a new issue over here with the same build log. So yeah, that's the creating an issue part. And if I go ahead and fix my issue, let's say I see this on my GitHub repository, and then I fix it. Again, I push the code. So I push the code. It should start another test now. Sorry, another build now. Yeah, so it's queued in another build. So this time, if it passes the G test, then it should automatically close the issue. So me as a developer, I don't have to worry about going and closing the issue. I only have to worry about my code. So yeah, it looks like the G test has passed since I wrote the right GPIO. And the flash is complete. So you can see the build was fixed and it closing GitHub issue number 25. So if I go here, now the issue is automatically closed. That's the whole thing. So going back to the PowerPoint, you can see that's the end of the demo, and that also brings us to the end of the webinar today. So what's going to be the take-home message? The take-home, sorry. So the take-home message is going to be that if you can see this the continuous integration, continuous testing platform as a elaborate movie or a play where you have these 3 main actors, CMAKE, Jenkins, and GitHub. And if you define their roles correctly, you will be able to you can continuously integrate and continuously test your codes and all your application for. In our case, we did it with STM32 Blue Pill. You can do it for Raspberry Pi. You can do it for Arduino. You can do it for any testing, or you can in general do it for any embedded application that you have. So that's the central idea of today's webinar. So if you have any questions, you can unmute yourself and ask, or you can put it in the chat. Be glad to answer. Any questions? Let me just check the chat.
Vishnu, am I audible?
Yeah, I can hear you.
Yeah. So, you said that G-test will be run after the fetching of the code from GitHub, right?
Right.
Are the G-test will be developed by you or it will be automated?
No, the G-test we will define it. So in this case, so even when it comes to the G-test of embedded systems, it's a bit difficult to access all the core layers. So we have to do it in a very we have to first of all decide where exactly can you perform G-test. So depending upon that, you will have to write the G-test code. So that part, but then the execution of the G-test, that is how the G-test executes. So CMAKE has a command called ctest. So it uses ctest to run your G-test part. But how the definition will be done by the application, the programmers. Yeah.
Okay. So, and after that, this continuous integration and this in order for this ANCT, that hardware has to be connected. I mean, 24 hours, right? Like every time.
That's a very good question, because in this case, at least the hardware is connected to the PC where Jenkins is running.
Okay.
So, but it does not have to be that. The hardware just needs access to the server. So suppose you do not want the hardware to be physically connected.
Okay.
You can there will be a one more layer in between your Jenkins and your embedded systems, which is known as over-the-air drop. This is what
So over
happens.
there. Okay. OTA.
Yeah. This is what happens in your mobile phone. I mean, you are connected to a server and then it updates over the server.
Yeah. So
Or
the
any.
hardware.
Yeah.
The hardware should have some Zigbee or Wi-Fi kind of
Right.
component.
Or it can even have Bluetooth. You can connect to your mobile, and then it can take in from there.
Understood. Yeah. Thank you. Thank you so much.
Yeah.
Okay, but in the case of vehicle automotive ECU, then this ECU is connecting a kind of vector cancase to convert the commands to flash the ECU, maybe something like this, in the computer that connects with the Jenkins.
Right. So in the case of an ECU, if my understanding is right, you can most ECUs have, I think, at least the ones that are in the newer models of the cars, have access to the Wi-Fi or some sort of a networking protocol. And usually most of these ECUs, at least the central ECUs, will be running a microprocessor, and in that case you will have an option where your firmware can be rolled back, as in it will have it is not just a flashing that's going to happen, it will be a bootloader operation. So if your bootloader operation does not go properly, and I think your bootloader also has support for OTA, it's over the air drop. So if it has support for OTA, it's a two-way process. I think first the flashing occurs, and then there's a verification, and if the verification fails, it reverts back to its previous firmware. I hope that's what you were asking.
Yeah. I think it's enough, because you are right now talk about this hardware, this STM32. So
right.
Just to clarify.
Okay.
But I believe the idea is the same.
Right. Yeah, that's true. Let me just, if anybody has any other questions, we still have, I think, 2-3 minutes to spare. Let's check the chat.
Just about this presentation and the recorded that was done, this presentation will be available for us. Can we share with us after that?
You mean the slides? You mean the PPT files, right?
Yeah, maybe the slides, the information. Then
I am not sure about the slides part. I can get in touch with my boss and see if we are giving out the slides. But then this webinar will be freely available on YouTube.
Okay, great. Yeah,
Okay, yeah.
I believe then I don't need the slides because it's recorded.
All right. Okay. Okay. All right. Then if there are no more questions, I think we can wrap it up. All right then. Thank you everyone for joining today's webinar.
Thank you, Vishnu. Thank you so much for your wonderful
Thank you,
presentation.
Vishnu.
Have a nice day.
Yeah.
Bye.
Thank
You're
you. Very
welcome.
good information. Very good webinar.
Yeah.
you.
Thank you. Bye.
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 Bye.